Hey everybody, welcome back to yet another fun and exciting Algebra 2 class. Today we're going to be jumping into lesson 7.5, talking about exponential and logarithmic equations. What's different from this, from what we've been covering before? Well, the only difference really here is that we are going to be doing equations and not just expressions. So they're going to equal something. Something's going to equal something else. We're on page 353. And on page 353, you will see the very first thing that they give you is a table. It says table B. This is a very, very important table. You need to kind of understand the concepts to this table in order to understand where we're going in the lesson. So let's start there. Number one. Look down at the screen. I've got it written out. You can look in your book as well. The equality properties of logarithms and exponents. So, number one, if the bases match, then the exponents must be equal. Let's say that we have, and I'll just use random numbers. If I say we have 3 to the x equals 3 to the y. Well, because of this equal sign right here, it has to be equal. In other words, what has to be equal? Well, this expression has to be equal to this expression, right? Yeah, because this says that it's equal. So, if we have the base the same, what does that mean? Well, that means that x must equal y. It has to. So, if x is 5, then y is 5. If x is 2, then y is 2. Whatever x is, that's what y is. Okay? So if the bases match, then the exponents have to be equal. Okay? Very important to understand that. All right. And you think, well, that's easy to understand. Well, just wait until we start going a little bit, and then we reference this back. You'll start to get confused about it. But if you can keep this kind of in your mind, okay, well, that's what that means. When we come back to it, hopefully it won't be so hard for you. Number two, if the exponents match, then the bases must be equal. If the exponents match, then the bases must be equal. What does that mean? Well, now let's do it this way. So let's put an x cubed equals y cubed. Okay, so now we have the base, we have the exponents matching. Look, we have 3 matches the 3. So what does that mean? Well, then that must mean that if, again, this is equal, then x, again, must equal y. It has to. Okay, why does it have to equal? Because if it doesn't equal, if that x is 1 and the y is 3, then those two things are not equal. Okay. Number 3. If the bases match, then the arguments must be equal. What are we talking about now? These first two right here are exponential. Okay, exponential. Number 3 and number 4, we're dealing with log. Okay, so these are logarithmic. What does this mean? Well, you have to go back to remember what is the argument, what is the base, and all that stuff. Well, let's write it down. Let's write an example of this. So if log A and then x equals log A y. Okay? Well, what is the argument? What is the base? Well, this is the base, A and A. So if the bases match, and in this case, the bases match, A equals A. Yeah. And we could use a number there if you want to. Then the arguments must be equal. What's the argument? The x and the y. That's the argument. So x equals y. It has to. Okay, why? Because this says that it's equal. What's the only way to make this equal? Well, the bases match, and so the arguments must match. Number 4. Again, we're kind of doing the same thing here. except for we're switching up the words. Okay, so if the arguments match, then the bases must be equal. So what does that mean? Well, now this time we have log of, let's call this log of x, a, equals log of y, a. Okay? Well, if the arguments match, what are the arguments? Well, it's this and this. So they're both a. A equals a. What must also be equal? The bases must be equal. So x must equal y. Okay? Now, you think right now that those are basic concepts, and they are. But once we get into some problems, those concepts they're not so basic anymore. So what we'll have to do is we'll have to kind of go back to those and just refresh our memory as we're going through some of these. So if you'll go down to the example 7.5a, here's the example. We have 3 to the x equals 243. Now, right now, probably what you're thinking is, wait a second. So this side is an exponential, and this side is just a number. Well, it's still what's called an exponential equation. Why is it an exponential equation? Because we have an unknown exponent. That's important to remember there. We have an unknown exponent. So what should we do? Well, what we should do is we should try to find one of these principles up here that we can make this thing kind of match up with. Well, it's an exponential, so what does that mean? Well, we're going to use either 1 or 2. We're going to use one of those ones because it's exponential. So, do we have something that we can make the bases match, or do we have something that we can make the exponents match? Well, if you come here, what probably the best thing to do in this one is try to make these bases match. In other words, we have a base of 3. We can't really make this, we can't just put an x over here. It's not going to work out for us. So if we make this base match over here, now it's a little bit tricky, but what you can do is take out your calculator. So what I want to put here is I want to put my base, which is 3, okay? Because remember, we're trying to get the bases to be equal. We're trying to get that base 3 over on the other side as well because we want to get the bases to be equal. Why do we want to get the bases to be equal? Well, that way we can find out what the exponent is because that's our goal here. We're trying to find out what x equals. So how do we do that? Well, take the number 3 and just exponentiate it. What does that mean? Just see how many times you multiply it or to what power do we get it. So if I say 3 to, then we could just try different things. 3 to the, obviously it's not squared. Obviously it's not to the third. Maybe it's to the fourth. 3 to the fourth equals 81. No. Let's try that again. 3 to the sixth. Well, that's 724. Wow, that's a big difference. So it must be 3 to the fifth, right? So 3 to the fifth equals 243. All right, so that's important information. So now what we need to do is come down here and say, okay, 3 to the x equals 3 to the what? To the fifth, okay? How do we know that? Well, we did it on our calculator. We figured it out. We exponentiated that number right there, or we tried to say, okay, I know 3 is my base. That's the base that I want to have. How can I write 243 with 3 as a base? Okay, and so we figured that out, that it's 3 to the fifth. We did a little trial by error there to figure that out. And we came out with x squared, or 3 to the x equals 3 to the fifth. Now, let's go back up here to this again, and if the base is matched, then the exponents must be equal. So the base is matched now, so what does that tell us about our x5? It means x equals 5. That's what it means, okay? So there we go. We solved our equation using our first principle. Okay, let's scroll down here and let's look at log 2 of 40. This is on page 353. Log 2 of 40 equals log 2x plus log 2 5. What are we going to do here? Well, the first thing we want to do really is take this side and condense it. Okay, it's expanded right now. So we want to condense that thing down. What does that mean? Well, this is going to be, we're just going to rewrite this, log 2 of 40 equals log 2 of what? X times 5, or 5x. Okay? And that's, you have to go back to remember how to condense logarithmic equations, and there you go, just condense it down. Now what? Well, now we're looking at logarithmic, so what are we going to use here? We're going to go back up to one of these, either 3 or 4. So do the bases match or do the arguments match? Well, let's go back and look at our base. Look, our bases match, 2 and 2, okay? So if our bases match, what does it say? It says that, let's go back up there to that. If the bases match, then the arguments must be equal. So here's what we're going to do on this one. It's really kind of easy. We're just going to cancel our log 2. Why are we going to cancel that? Because our property tells us that we can do that, because it says that these arguments must be equal if the bases. Now we can only cancel it if the bases are equal. You can't cancel it if the bases aren't equal. All right, but they are. Log 2 and log 2, they're the same. So now we end up with 40 equals 5x. Now we just solve that. Divide by 5, and we come up with x equals 8 would be the answer there. X equals 8. Okay, that wasn't too bad. Once you kind of get these properties down, they solve out pretty easily. Not too bad. The problem is kind of forgetting what to do in what order. All right, so let's do this one. E to the negative x squared equals e squared times e to x. Whoa. It's not as hard as you think, okay? It's really not. Now let's kind of think about what are we dealing with here. Well, here's what we're dealing with. Look, base, base, base. E, E, E. What does that tell us about the bases? Well, they're equal. Well, what do we know about equal bases? If the bases match, then the exponents must be equal. So what can we do here? Well, what we can do here is we can just cancel the E, E, and E. How can we do that? Because they're equal, so that tells us that this must be equal. One thing that you really probably need to do first is combine these, because if you don't, you'll forget to do it the right way. How do we combine exponents? How do we multiply exponents? Well, we add the exponents. So in other words, that's going to equal e to the x squared plus 2x. And we can kind of condense those down. We can kind of join those together. How do we do that? Using our properties that we've already learned. All right, so that would be e to the negative x squared. And then at this point, we would just cancel the e's. If you cancel the e's first, here's what's going to happen. You're going to think that this is just x squared times 2x, and it's not. Okay, it's plus 2x. Why is it plus 2x? Because they're exponents. Okay, now we just solve this. Well, how can we solve this? I would take everything to one side and then factor it. Use zero factor property and do it that way. So plus x squared plus x squared, that's going to cancel that. It's going to give us 0 equals 2x squared plus 2x. What can we factor out? Well, we can factor out the 2x. So I'll come back up here because I'm almost running into my next problem. So I'll come up here and we'll get 0 equals 2x, that factored out. And then what's left? So if we take our 2x and we divide everything, we end up with x plus 1. Okay. Well, then when we solve this out, we remember zero factor says we set each equal to 0. So that's going to be 0 equals 2x and 0 equals x plus 1. Solve this out, divide by 2, divide by 2. We're going to get 0 equals x. So that's one solution. And then over here, we're going to subtract 1 from both sides, and we're going to get negative 1 equals x. That's our second solution. Okay, so how did we know that we were going to have two solutions? Because we had a squared in our exponent. As soon as we knew we had a squared, we know we're going to get two answers because squareds always give us two answers. So there you go. You can kind of rewind that a little bit and watch it again if you need to. But I think that the algebra there is fairly simple. It's just a little bit of factoring. It's just a little bit of zero factor property. The biggest thing is right here where you're actually converting it to the algebraic equation. All right, let's go ahead and do one more, and that'll finish this lesson. There is more to the lesson, and I'm going to do a second video for the second half of the lesson, but I don't want to put too much in one lesson. All right, so here we go. How are we going to do this one? This one's got a lot of different stuff going on here. This is on page number 354, if you want to look at that. Well, what we need to do is we need to turn it in. We need to say, okay, what is the same? And what's the same is our log 3. Our bases are the same, right? Okay. And so we can turn it into basically a log 3 problem. How do we do that? Well, let's condense it. Okay. How do we condense it? Well, that 2 goes here to be an exponent. So we get log 3 x squared. This minus means we have a division problem, okay? And then the log 3 is the same here, and it's divided by x plus 6, x plus 6. And that all equals 1 still, all right? Now, this is an interesting step right here. Again, we can't really do anything with it right now because it's in log 3, and this side is not in log 3. So how do we do that? Well, one thing I could do is I could just switch this to an exponential problem. And I could write this using an exponent. How are we going to do that? Well, the base is 3, right? Okay. One way that this kind of happens here, and this is a little bit overcomplicating it or oversimplifying it. I'm not sure what, but if we divide both sides by log 3, okay, that will cancel that over there because we really want to cancel this. Okay, so now how do we handle this over here? Well, what we want to do there is we want to turn that into an exponential. How do we do that? We invert it, okay? And when we invert it, this becomes, if you remember from previous lessons, this is going to become 3 because that's our base to the 1. This is going to be our exponent. So this is going to be 3 to the 1 over here, 3 to the first power, okay? And so then we're just left with this right here. So we have x squared over x plus 6 equals 3 to the first power. Why did I keep that with the first power? Well, because we are doing it using exponents. In this case, the 3 to the 1, we can solve that. There's no variable up there, so it's just 3 to the 1, which is 3. So we can just get rid of that 1. And now we can just solve it out. We're solving for x, remember. How do we do that? Well, we need to get this over to the other side. So we're going to multiply by 6, x plus 6. So we're going to multiply over here, x plus 6. That's going to cancel that out. We're going to get x squared equals, and we can distribute that through 3x plus 18. And now we can move the x squared over, because again, we're going to want to factor this one, minus x squared, and that's going to cancel. We're going to get 0 equals negative x squared plus 3x plus 18. I don't like that negative sign right there, okay? So let's multiply negative 1 times everything. Let's change it. So we're going to get 0 equals x squared minus 3x plus 18. And now we can go ahead and solve that out. Oh, minus 18, sorry. All right, minus 18. There we go. That's better. And now what we want to do is we want to factor that and solve that. So what does that factor out to? 18 factors out to 1 and 18. It factors out to 2 and 9. Again, we're trying to get this -3 here. It factors out to 3 and 6. There we go. That's what can give us the -3. So we're going to have x minus 6x plus 3. And again, this is still all equal to 0. But we do the 0 factor property. We set them both equal to 0, plus 6 plus 6. We're going to get x equals 6 over here. And we're going to do 3, -3 to both sides there. X equals -3. So those would be our two answers on that one. Lots of fun, right? And then you can always go back in and check those by plugging those into your calculators. If you might need to do the change of base formula on that check because of the log 3, if you remember how to do that, go back and watch that video if you don't remember how to do that. Some of your calculators are equipped with that function where they have log and then the little square where you can put in log 3. So in the original on this one, we had log 3. So you'd have to put a 3 into that if you're going to check these in your calculator. If not, use the change of base formula. Okay? All right, lots of stuff going on there. A little bit of a complicated lesson. Hopefully you were able to kind of think through that and understand it. If you didn't, rewind it and watch some of those concepts again so that you can get it. All right, well, that's all I have for you. Hope you have a good rest of your day. Bye-bye.